Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. Today's episode is brought to you by, well, you, actually. We've been reflecting on the podcast, its history, and the incredible feedback that we've received from listeners across the world, and we're absolutely floored by how many of you really care. I mean, it takes a lot of energy and brain power and effort to put this podcast out while we're simultaneously growing positive energy, but we could not be more thrilled about each one of you out there listening and participating in this incredibly important discourse that's so badly needed in our industry. So here's the only thing that we're asking of you. Please take a moment, go to iTunes, and give the podcast a review, and then send the podcast to someone you think might care. Our audience only expands as the reviews come in and more people are out there sharing. You all mean the world to us, and we can't say thank you enough. Enjoy the rest of the episode.
Welcome to the Building Science Podcast. Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello everybody, and welcome back. Welcome back to the Building Science Podcast. I'm Christoph Irwin, here with my trusty companion, Miguel. As always. And today I have the pleasure to introduce to you Stephen Colley. Please say hello.
Hello, everybody.
And today we're going to be talking about something that we have touched briefly on before, and that is monolithic wall assemblies. If you go back to the Living Inside Everywhere series, where we did one episode each on the rain, air, vapor, and thermal control layers, I'm certain you'll hear embedded in there this idea that the current construction paradigm of lightweight building assemblies that are massively layered is not necessarily the only way to do it. In fact, is not the only way to do it. And so I have been looking around for people to interview since then to talk about monolithic wall assemblies. And I met Stephen, I guess about a year ago now?
About a year, yeah.
And down in San Antonio at a design charrette that we were doing on integrated project delivery with the COAT group down there with AIA. And we've been talking ever since. So finally got him into the studio to record a podcast. And here we go.
Yay.
So Stephen, please tell us a little about yourself, your background, and then we'll get into the podcast proper.
Okay, I'm not native to San Antonio, but I've been there for about 60 years, and so that's almost native.
Well, I guess eventually you can call yourself native.
I'm an architect. I went to the University of Texas at Austin, graduated in '76, and got the bug for environmental appropriateness even in those years, and worked myself way through a lot of architects' offices in San Antonio, and fell in with Bill Sinkin in San Antonio at the time, who was wanting to do something environmentally appropriate and to launch Solar San Antonio. And I said, well, that's icing on the cake. Let's do cake. Let's do a green building program like what Austin's done. Fantastic. And so it's really grown from that. And so I was the program manager at Build San Antonio Green, writing the residential green building program. And it got to a point where I said, it's got to be better than this. It's got to be better than this. You know, we could help the builders, come to a point where they're doing the right thing. And the builders, by and large, are doing that, some by choice and some because we've got stronger codes now. Mm-hmm. But we can do better. And always being a fan of Earthen construction, I said, this looks like the right kind of thing. You can't get any more green than soil.
Yeah.
And so the attributes of earthen construction were just too overwhelming to ignore and just too compelling to turn your back on. It's historically appropriate, and culturally it's like all over the planet, and we used to have it here too. I've got even have a small TED Talk where I go into,
really?
Oh yeah, how come we're not building like this anymore? And it's a cultural change. And so
it's sort of like the way we use oil to use as fertilizer to grow food, so it changes the way we deliver food to ourselves. And now we use so much energy in our buildings for conditioned space that we can rethink old practices, right?
Yeah, exactly. Yeah, and we could do the right thing for the wrong reasons, but we can also do the wrong thing for the right reasons. And so I think it's time to do something different for better reasons. If we really get down to what are we really trying to do with our buildings and our residences.
Mm-hmm. Mm-hmm. So I can think of two questions that I want to start out with. One is defining earthen construction, and then the second, maybe in this defining it, you can tell me if we can use local materials, or is it you have to have special materials delivered from somewhere else? So
well, depends.
Start by defining earthen construction.
Earthen construction is a construction that uses basically soil, and mixed in the soils is usually clay and sand and silt, and the proportion of those is very forgiving. You can have roughly 15 to 20 to 25% clay and come with some successful structures. Some people are actually playing with even higher percentages of clay. If it's too sandy, the blocks fall apart, and if it's too much clay, well, then they expand and contract too strongly. So there's a wide range of what works. And so if your soil that you want to use from your particular site is got too much sand, well, just order up some clay, and vice versa.
I get it. And what about silt? What is silt?
Silt is defined as by the particle size. So the particle size is quite small. If I recall, it's smaller particles than clay. And
interesting.
And so.
And it's all organic materials, and you've made sure to get out anything that's like sticks and leaves and
that's correct.
Things like that.
Yeah.
Excuse me. No, it's inorganic materials.
It's inorganic, right? Yeah, we don't want to use straw in the earthen construction in the way we're doing it modern now. However, straw was used in the earth construction in other cultures.
It's like a binder.
I always thought it was a binder. Some people have told me it helps to draw the material out. You dry the material
moisture.
out. Yeah,
I can see that.
And so,
like a wick.
Right, and it's even biblical. They even talk about Pharaoh had kept the straw from the people who were building the mud huts.
Oh, right.
And you could see historically that particular period when the Pharaoh said, "Okay, we're not going to let you use straw," and they could actually find the blocks that were made without straw. Really fascinating stuff.
Wow. So
it's not new. When I go around and talk to people, I said, what is the oldest continuously occupied structure in the Western Hemisphere? And people were trying to figure out, well, what could that be? It turns out it's probably Taos Pueblo. They've been living there for at least 700 years, maybe 900 years.
Wow. And
always without electricity, without air conditioning, and there's something to be said about that.
Mm-hmm. So I'm thinking about the listeners right now, and it might be that the listeners are thinking something along the lines of, wait a minute, why are we thinking about earthen construction at all? Like, before we really get their interest up to understand what it is and how you do it and what are the benefits. How is it that you came to want to do earthen construction in San Antonio?
Well, that's a good question. But what I see in it is that it's just a very simple material that's been around, like I said, thousands of years. And the people who are still doing it have really been able to figure out and doing it right. There are many countries who have earthen building codes.
Interesting.
Yeah. We could talk a little bit more about this later, but the Earthen Construction Initiative, one of the things that we're doing is doing research. Okay. And the research arm is actually going out and getting copies of earthen codes from countries who are already doing it. For example, New Zealand, Peru, and
New Zealand is doing so many good things with buildings.
Oh yeah, New Zealand is fascinating.
They're always on the list.
And the nice thing about some of these too is that some of these countries are in the Ring of Fire. So they've got seismic issues too, because seismic consideration is very strong in earthen construction. There are stories of historical earthen structures in Iran, for example, that have been destroyed by earthquakes. And there have been hundreds of people who spent some time to say, why did they fail? What was why are the ones that are still standing? Mm-hmm. So there are some very smart technological minds out there figuring out, okay, it works here, it doesn't work here, and we've got a Temblor, what are we going to do when that happens? And how can we do it affordably? And in Peru or Chile, I can't remember which, they even have a shaker table in the university that you can put a full-size earthen house on, and they'll shake the heck out of it and say, okay, what can we do that works? And one of the things that works, they take chicken wire and they go above the lintels, or above the doors and windows all around, and cover with plaster. Oh, and they nail it in place using beer bottle caps and nails. So it's like real low tech, but just one simple thing goes really far to keep these things from crashing in an earthquake.
Very, very cool.
Yeah.
So just from the basic perspective, though, let's say I'm an architect and a client comes to me and says, I really want to do a fantastic house, one that has low embodied energy, but is also, for my family and myself, is healthy and comfortable and durable and low maintenance and energy efficient. Mm-hmm. So maybe we'll just run through those sort of briefly. Let's try to go brief. So the health aspect would be getting into, the health and comfort both would be getting into stabilizing humidity in the space.
That's right. You could do that. We're finding, there was a study a few years ago by John Maroney in Del Rio, and he found out that temperatures inside earthen test structures were cooler at 3 in the afternoon than they were at 9 in the morning.
Wow.
Without air conditioning.
Wow.
And he went further to find out, well, why is this happening? All of the people who were, really into, dense structures and thought it was thermal mass. We thought it was because it just takes a long time for heat to go through material. And he says, no, there's something else going on. And he did some initial studies to find out that these blocks were damper at dawn than they were at sunset.
Interesting.
So the blocks will absorb moisture overnight, and then the next day, the heat of the day makes that water inside the blocks evaporate, which requires heat for evaporation to take place. And pulling heat out of a room will make it cooler, and there's voila, there's his numbers. But
interesting.
Yeah. So what we really want to do now, Christoph, is we want to, in the Earthen Construction Initiative, do research, data logging, and be able to really quantify what's going on. What is it? How fast? When? What kind of conditions? So that we could eventually, what we want to do is modify and create, earthen construction codes, and even help mechanical engineers so that if they're faced with a design that's maybe 1,000 square foot house, or it could be any size, and if it's earthen walls and maybe even earthen roof, how much tonnage of air conditioning can be taken out if this really happens? Mm-hmm. And what are the effects on the humidity?
Right. Now we're into the comfort aspect of it.
Exactly.
The temperature will be stabilized somewhat because of the mass effect. Mm-hmm. I'm tempted to talk about putting holes in it for windows and doors, but we'll come back to that. So we've covered health and comfort.
One more thing about health.
Oh, please.
Is that soil is soil. If you take a look at the conventional house, you've got probably 9 or 10 layers of materials, sheathing, house wrap, plywood, and now you've got glues, and you've got urea formaldehyde, so you've got all sorts of things that are in conventional construction you will not find in earthen construction. So you're already, with the very structure of the house itself, a very, very healthy house as far as indoor air quality with toxins is concerned.
That's huge, yeah. And so we have an episode coming up on indoor air quality, and in fact, if there's a succinct list of rules for indoor air quality, it is in fact be mindful of what you're bringing into the space and what the space is made out of, and what that introduces into the breathable zone.
Oh, I know. I cannot emphasize that greater. When I design houses for clients, I try to give them a healthy housekeeping book. I said, now that you got this clean house and you've got a minimal number of toxins, don't screw it up. Mm-hmm. There's things that you need to kind of be wary of.
Yeah, cleaning products is a big one, and air fresheners, which are completely inaccurately named.
Right. And so so there's two aspects there right there that I think are pointing toward earthen construction as being superior to conventional.
Absolutely. Okay, so health and comfort, and the comfort it's well known. The mass effect is a way to stabilize temperatures, and there's a solidity to that. It can work independent of mechanical systems, and it can be supported by mechanical systems as well.
Right, and we want to find out what that mix is. We want to find where that sweet spot is. Pacific National Labs, they're interested too, but they don't have the drive. They don't have really the demand yet to do a lot of studies on it. And so we're looking at the grassroots level to try to find people locally with
Yeah, and we're in a climate where it
to
seems
do it.
like it would be of benefit.
Oh, absolutely. Yeah.
The high humidity. All right, so durability and maintenance. Like, what does that look like? How do you maintain an earthen building?
Well, what a lot of the historical buildings, like the cathedrals or churches or something that are out in the desert, a lot of times they'll have like a big party once a year where they'll get the people together and they'll look for little cracks. And they'll find a crack and they'll just get some mud and they'll just shove in the cracks and they have a party.
So the same material it was built out of.
That's right.
They put it in the cracks.
That's right. And when you're doing compressed earth block, for example, the quote-unquote mortar that goes between the blocks is the same makeup as the blocks itself. And so once it dries and becomes part of the block, it's a monolithic structure. Mm-hmm. And so, you just use the same mix.
So it is 2017, and we have more modern materials available. Mm-hmm. Is there, indigenous cultures might have chosen some other materials had they been available. Are there materials available to protect the outside? What I'm thinking of is, frankly, driving rain, downpour rain.
I'm so glad you brought
My
that up.
My building is, making a muddy stream.
Oh, I know, and that could happen if you're not careful or if you're not stabilizing the block. A lot of.
Okay, so it should be stable enough that a downpour will not dissolve my wall.
That's right. That's right. One of my favorite guys out there building with this material, Jim Halleck. He had this story where he was a purist and didn't want to have stabilized block, and then big huge storm came up one night, and he had to go run out to the building site and try to pound tarp into the walls and keep it. And he said, "That's it. I'm going stabilized now."
And so what does that mean, stabilized earthen construction?
Okay, stabilized usually means that you're using a material. Sometimes it's lime, sometimes it's Portland cement.
Interesting.
And some people in the New Mexico or Arizona, they will use like an asphaltic material.
Interesting.
And so it depends on but there's a lot of things that you can do.
Yeah.
Now, a lot of people who say, well, we don't want to use Portland cement because the high embodied energy. But we're talking about 4%, maybe as much as 7 or 8%. And John Maroney was doing some further tests to see if the percentage of Portland cement affected the transvaporation effect. And he claimed he didn't find any noticeable problem with that. But we need to do more detailed data to find out for sure.
And so when it's stabilized, so what would happen, I don't know, let's say it was a flood or something like that. Is it stabilized enough that even that?
I saw a house done before I really started getting into it that was on the Guadalupe River banks. And it was somebody was using it as a wine cellar, even had it like a basement in it. And they had one of those really huge floods that, I saw it before and after. And on after, I came back, and all of the other houses, they were just slabs. There was nothing. Wow. And this thing was still there. The roof was a massive steel roof, and it was there too. And he said, those cypress trees along the Guadalupe, they were floating down and banging into things. And, I couldn't see any damage at all.
Wow.
It's really that incredible when it's stabilized.
So it's
block.
like a little bunker you're building. Not a little, but it's it's very sturdy.
I've got a photograph that
we can link to the show notes.
I'm going to put to the show notes. It's a photograph of a compressed earth block machine, one of the machines that's made in San Antonio. It's in the foreground. And in the background, you'll see a compressed earth block house where the walls are there. The roof is gone, but then you realize that this machine in the foreground's all beat to hell. It was picked up by a tornado and relocated a couple hundred yards away from the job site. All of the other houses, we're talking about slabs, bare trees and everything. But here's this machine banged up, and in the background, you can see the walls of this house that had been through a tornado.
Wow.
And
so safety, not just health, comfort, durability, and efficiency, but safety.
And another thing that's kind of a plus is that dirt doesn't burn.
Fire.
So you got fire issues too. There was, the Bastrop fire. Uh-huh. There was a woman who rebuilt in Bastrop, and she said, I don't want to rebuild another wood structure. She builds compressed earth block structure. She had another fire that came right up to her house, and that was it. It didn't destroy her house a second time.
Beautiful.
So it's just like so many
benefits just all add up.
Yeah, and we're hoping that the insurance companies will kind of pick up on it once we have enough houses that are out there where they could say, oh, well, guess what? Your insurance rate can go down because your house isn't going to burn.
Beautiful. That's beautiful. So the last one, so health, comfort, safety, durability, energy efficiency. I heard you say that it's sort of TBD a little bit on exactly the impact on the mechanical system, but as a physicist and engineer, we know that we have a higher mass assembly, so it's a thermodynamic flywheel. Mm-hmm. And so just implicit in that is that means I can choose when I cool the structure down, because it'll coast a little longer, let's say through the afternoon, and I can cool it down in the morning and have it coast through the day and then cool it down again in the evening after sunset.
Right.
When my system runs more efficiently.
Yeah, I mean, the way I see it is you're using the best of prehistoric materials with 21st century technology.
That's a great way to say it.
And it's the marriage that's made in heaven.
So you don't have to make a comfort sacrifice or anything.
Oh, God, no. No, not at all.
Okay, but then the other aspect of energy efficiency, which is not accounted for typically, there are some programs that account for embodied energy, and embodied energy includes harvesting it, collecting it, refining it, putting it into its form where it was used. Like OSB has a lot of embodied energy, steel tremendously so, 2x4s. So I would imagine the transportation, you're not moving this stuff as far. You typically try to take it right from the site and then augment it.
Well, most of the time, people have their favorite quarries. Like a quarry will be a place where you'll get the raw materials, and they'll either make the blocks at their shop or at their plant or at the quarry, and then it's a matter of moving the blocks to the site. But, it gets pretty expensive if you're going too far. But there are earth quarries all over Texas, let alone all over the planet. You don't have to really go too far,
So I'm in downtown Austin with you right now. If I wanted to build a guest cottage in my backyard that was made out of earthen blocks, do you know where the quarries are? You'd ask
Personally,
around?
I don't, but some people would.
But in San Antonio, you
know. Yeah. There's some really sweet ones around Fredericksburg area, for example. So if you're in Fredericksburg, Dripping Springs, and that area, there's places where you can get some really good stuff that's already pretty much mixed and ready to go, or about mixed. There's a little bit of... you sift out the big rocks, for example, and it's just a real simple screen, that just kind of looks like an A-frame. You just kind of bang it into that and pick it up from underneath. And you have it screened a little bit finer for the plaster.
But the quarries, so I can't take the materials from my site, or could I dig down and test
You might. You want to get below the organic layer. Okay. So
and here I have caliche. I know. I've hit that. You can't do a caliche block.
I'm not 100% sure. Probably not.
It's some sort of clay.
You need clay to really bind it really well. But it's easy to test, and one of the easy tests that people use, sort of a seat of the pants, is like what they just call mayonnaise jar test. You put the soil in a water matrix and shake it up, and you'll see how it falls out as far as clay, silt, and sand. And if you need to augment, you just buy what you can to augment. So some places you can use the soil right there on the site. If not, you don't have to go too far. But I think arguably, when we're talking about embodied energy, it's still, I think the earthen construction still wins when you consider what's involved in milling wood, and like you said earlier, concrete and steel. And
huge.
And if you're using...
And glass.
Right.
But these buildings will still have windows.
They still have windows, they still have doors and all that. And like I said, if we're using a Portland cement as the stabilizer, it's a fairly low percentage. And then it comes a question is, what have you got for your foundation? If a foundation will probably be more massive than standard homes if you're using a typical foundation.
Understood.
But we're also looking at a type of foundation where you don't need as much concrete or steel.
And what is that?
Well, it's what the colloquially known as, like a rubble trench foundation.
Rubble trench.
Yeah, and there's also another name for that some engineers would prefer to use because it doesn't sound like it's trash. Rubble just sounds so pejorative. So.
What's the other name?
I wish I remembered.
Okay. If you do, just insert it in.
Okay.
Okay, so we've got health, comfort, safety, durability, energy efficiency.
Yeah, what else you want?
That's pretty much it. So what about windows and doors? And then I'd like to really dig into what it is and how we build these walls. But so the windows and doors, it seems like you, just from the outside looking in, you're going to need Hey, that's a good pun on windows and doors. A steel beam, a massive wooden beam or something.
As good. I'm glad you brought that up.
So what's the header?
Usually the header can be a lot of different materials, but at the top of the walls, you're going to have a bond beam. And the bond beam will usually be a concrete beam that's at the thickness of the wall. It'll have a couple of rebar in it. It's
interesting.
It's like the belt, when you're talking about the stresses that happen at the top of things. It just kind of holds the structure together at the top.
That makes sense.
Yeah.
And that's standard cement, reinforced cement. You put forms up and pour it.
Right.
So then that means you could have a long window or a very long door.
Oh yeah, you have any kind of lintel could be made out of that. You can make it anything you want. Right?
And then if I don't want my window head to be all the way up there at the bond beam, how does that work? I pour the.
You can have a lintel above the window and door, and then you can have earthen on top of that, and you have a bond beam on top of that. So.
Okay, so
you don't have to have that lintel be the bond beam itself.
Mm-hmm. Okay, so let's talk about now what is earthen construction. As I understand, there's two main types. There's rammed earth and earthen block.
That's the primary ones we're looking at, but we don't want to turn our back on the more decorative things that are going on, like cob construction. Cob construction is very, very handmade and very, very organic. If you type in cob houses in Google, you're going to see some really, mystical sort of looking things that are very, very sculptural. Very few straight walls and, mantelpieces that actually become bookshelves and just amazing artistic stuff. Now, the trouble with that is that's going to be really challenging for us to attack for having a building code for. And so that kind of construction, you're going to be out in the county doing it.
Yeah, because it's so subjective. I mean,
exactly.
And the variation in quality.
Yeah.
I've actually read that the rectilinear straight lines, flat walls, flat ceilings that we build with, there's actually a biological benefit to having more organic shapes and amorphous.
There probably are,
and
that's all related to like feng shui aspects and biobiology and all sorts of other things. And I think there's probably something to that, because there's nothing about the human body that's rectilinear, so why should our environment be the same?
Yeah.
And people have tried a lot of different ways and a lot of different times to do things that are like domes. Then they find out, well, how's my furniture going to fit in that? There's all sorts of practical aspects to why we have 90 degree here and there.
Right. And so if we want to have monolithic high mass assemblies penetrate the mainstream market, why don't we just go ahead and do flat walls and flat ceilings? Let's just start there, right?
But you can have some fun even when you're doing compressed earth block or rammed earth, because the ideal roof structures for those would be domes and vaults.
Interesting.
And
made out of rammed earth or
earthen materials, right?
So even the roof assembly, I hadn't.
Oh, sure, absolutely.
What does the rain land on? There's a water control layer.
That's right. You've got a water control layer, which is like a plaster that's where the water can run off.
So you don't have to have a metal roof or
you don't have to
tile roof.
No, I mean, of course, it's no.
So you have basically the rain hits a stabilized earthen construction.
Right. You're talking about like a plaster coating.
So okay.
And also there is a gentleman who's working on this material that's it's a coating material that's it's not elastomeric. It's a breathable material that you can put on earthen structures that also help fight off wind-driven rain. And we're in the middle of testing a batch of that right now, and we don't have the results yet. But it's like a milky sort of coating that's added to it, and so it's an added layer if we need to. So there's all sorts of things happening right now.
But you mentioned that one building where the tornado had, or was it the flood?
There's a tornado, yeah.
And there was a metal roof on it. So that was a standard.
Oh, that one, the flood.
Pitched metal roof.
That was not a this guy wanted to do something really. It was almost a bomb-proof sort of structure. This is a very serious metal frame roof. The metal panels were gone, but the frame of the metal roof was still there.
Wow.
So just peeled the roof panels off.
But he had an earthen construction with a steel-framed metal roof.
Right.
And it peeled the panels off.
Mm-hmm.
Okay, so you mentioned cob, but we've talked about rammed earth and earthen block. Could you describe, sort of briefly, I know there's probably big subjects, but what's the difference between a rammed earth wall and an earthen block?
Okay, well, the rammed earth wall is primarily you're using two forms, and you're putting soil into those forms, and you're tamping it down in place. And then that's called a lift. And then you put some more soil in, you tamp it down, and so you just do this layer upon layer upon layer.
You move your forms up as the wall height changes.
Exactly, yeah.
And that's also stabilized with concrete, correct?
Probably most of the time.
Mm-hmm.
There are some walls that aren't stabilized, but I think the majority of them will have a little bit of stabilization in them for sure.
Mm-hmm.
Now, compressed earth block is like rammed earth in the final product, but you take into advantage machine, and there's lots of different machines that will make blocks. Some are even manual, but arguably one of the best machines is made in San Antonio at
Interesting.
Advanced Earthen Construction Technologies.
Are you affiliated with them?
I'm not affiliated with them. I don't get any kind of kickback.
No, that's what I was
none
wondering.
of that kind of stuff. None of that. But the guy is just an amazing mechanic, and he's made these machines for years. They will make blocks. He has 3 different sizes machine, the small ones make like a 4x6x12 block that is such a lightweight machine you can pull it behind a golf cart.
Wow, 4x6x12. Is there a standard size block?
They've based it on the standard size, or roughly standard size Adobe block, which is 10x14x4, and that could be like 3 to 4 inches thick. But it's usually a 10x14 size block. And
the 14 is the thickness, or the 10 is the thickness?
The 3 or 4 is the thickness. And so
I'm sorry. No, like when you put it in the wall, what's the difference between the inside of the building and the outside of the building? It's not 3 inches.
No, the depth of the wall is either 10 or 14 inches, depending on how you turn the block.
Okay.
But the blocks are like big huge bricks. Yeah.
Uh-huh.
And so these blocks are roughly 35 pounds. And so this is something that's, pretty seriously will wear you out if you're to do it all day.
Yeah.
So there's the aspect of it that really you have to keep in mind too, is the labor aspect.
Yeah.
But
is it a DIY thing, or is there a
could
skill
be.
set you develop?
It's not rocket science. You could develop the skills, within a week with the right kind of teacher. And we just need to get more teachers out there.
And that's the skills to do the mix, the creating the block, the putting the block in place with the mortar.
Yeah, the putting the block in place is the easy stuff. I've been on workshops, maybe 3 or 4 different workshops. It's nothing to it, as long as you could, do line levels and know where you are, and just keep things straight.
Mm-hmm.
It's nothing tricky at all.
It's a lot like conventional masonry.
It's a lot
those
like
skills. I mean,
right.
Collecting those skills.
But the critical aspect, for example, the mortar doesn't have to be exactly 3/8 of an inch thick. It's a slurry of mud that you put down to put the block in, slide it into place, and it's a little bit sloppy, but you just kind of tap it until it's level and true to the wall. And
what are you tapping with? Rubber mallet?
Usually.
Your hand?
Both, but the mallet is going to be easier on your arm after a while.
Yeah, for a long time.
Yeah.
Okay, so rammed earth and earthen block are
compressed earth block.
Compressed earth block.
Yeah, and sometimes it's called SCEB, which is stabilized compressed earth block, as opposed to CEB. It's just a technical sort of thing. So, but when they talk about CEB, most of the time it's stabilized. But that would be SCEB. Okay.
Mm-hmm. And okay, so you have. I know you're part of the Earthen Construction Initiative. Are you the founder of it?
One of the original members, and I'm the president right now.
Okay.
Yeah.
So where I was going with that is, let's say I come to you and I say, Stephen, I know you know a lot about this. You've thought a lot about it. I want to build an earthen building.
Mm-hmm.
And what do you recommend? So what approach? Rammed earth? compressed earth block, stabilized compressed earth block, which...
The first crayon I'd pull out of the box would be stabilized compressed earth block.
Mm-hmm.
And I think we have, I don't turn my back on rammed earth because there's a couple of people in the San Antonio area that know how to do that, and they've done some really good examples.
Mm-hmm.
It just depends. We talk with the client. I would talk with the client and find out, why and how and what brought you here, and
smart.
We'll either go one way or the other with it.
Yeah, and I realized as I said that is that it's going to depend a lot on, am I doing it myself? Am I going to hire somebody?
Yeah, and how big it is, how elaborate it is. What are you trying to do? If it's something that's very, very easy and straightforward, well, maybe rammed earth is really the best way to go.
Mm-hmm. Can you do a 2-story home?
You can.
Interesting.
If you take a look at some of the volumes of books that are available on earth and construction, there are towers that are made out of earth and construction. Really? In Africa, there's a bell tower in Yemen, I believe, that looks like it's probably 80 or 90 feet or more, There is a place in Yemen called the Manhattan of the Desert. And these are 7, 8, 9, 10-story earthen structures that were built in the last couple hundred years. And it's just phenomenal. If you see a picture, I've seen one picture of it like at dusk, and you see electric lights on the inside. It just looks like,
wow.
I know.
And that's because the soil there, right there where they built it, was compatible with this construction.
Exactly. It's really funny when I do talks. I say, well, how come we're building with green now and we're doing green construction, green building, and what were we doing 150 years ago? Well, 150 years ago, every building was green building because you built with what you had, with what you've got, where you are, and you had some knowledge of the climate.
Yeah, it was off-grid, too.
You were off-grid, that's right. There was no grid, and you had...
net zero energy, net zero water.
I know, and you had non-toxic materials because all those chemists who came up with the toxins weren't born yet. So.
Better living through chemistry.
Right. And so everything was green building back then. I always think we need to borrow from stuff that's gone before. We shouldn't discard things just because it's old.
Mm-hmm.
We didn't turn our back on earth construction because we ran out of earth.
Yeah.
It was a cultural change, and it was a quicker, faster, better, cheaper way of doing things. And in the industry, mass production of nails really made a whole lot of difference.
I didn't know that.
Oh my God! Because at one point there was nails that were bang, bang,
blacksmith,
bang.
Yeah.
Yeah, one at a time. And you can't, there's not a whole lot you can do like that. But with...
interesting.
Yeah, the mechanism of mills to make smaller boards, after they torn down all the big trees and they got small trees, well, what are we going to do now? They came up with stud construction.
Mm-hmm. This is a little, maybe sounds like a dark vision of what's happening, but so we not only have relatively cheap interchangeable parts, but when it comes to this stick frame assemblies that we have the ability to use relatively low-skilled, exploitable labor. Because I can just say, okay, you're out, you're asking for more money, you're in, nail these studs together. I mean, it's not quite that simple, but there's this cost optimization that's built in. Well,
it's been a race to the bottom in the construction industry, in my opinion. We have builders, bless their heart, I love a lot of them, but they're in a very competitive market. One builder who will remain nameless proudly told me, he said, see that house over there that I finished? I said, yeah. I said, if I left one nail out of that house, it would not beat a code. Oh, my God.
Be proud of that.
Be proud of that? So that's what we're dealing with, because these guys are trying to sell a house, and if theirs is $5,000 less expensive than the competitor right next door, people don't know what the real value of that $5,000 is.
Yeah. Yeah.
If you show them an earthen house that might be 15% more expensive than conventional, who's going to want that unless they realize all these aspects that we had gone over earlier, as far as the health aspects, durability aspects, longevity, the value, all those things. You can't put a dollar sign on how sick your kid's going to be.
Yeah.
It's crazy. But
yeah. As a society, and even as mammals, right? There's the anthropologists in Miguel might know about this. We're not wired to think long term.
No, not at all.
You know?
Yeah.
Now. Yeah. So low first cost and visual aesthetics, that's a now. And yeah, I hear you. So you just mentioned the number. You mentioned a 15%. Is that your...
That is I can't tell you how ballparky that is.
Mm-hmm.
You know, that's just like because we really don't have the mass yet of people doing more than one-off homes. You know.
Ah, that's a good point.
You know, we don't have the structure on board to find out. Okay, now we've got a dozen. How much do they cost? And so.
Are there any proxies that you can kind of work with? For instance, the Earthship movement that's in Taos. Do they have any studies that you know of?
Not that I know of. And the Earthship is a whole different breed anyway.
Yeah, that's true.
You know, and a whole different climate thing.
Mm-hmm.
And it's I like what they're doing. You know, I'm really fascinated by that. And I'm fascinated by anybody who goes out there and builds with alternative materials. You know, there's a guy in Mason who's making a really amazing what's called a papercrete sort of material. And it's recycled paper, cellulose, and a matrix that has some Portland cement and a binder, which is like an acrylic binder. Mm-hmm. And it's amazing stuff. And he's one of his possible sources of that are the scraps left over from Kimberly-Clark, you know, Huggies. Where they've got to find a way to get rid of it. He takes it and makes blocks out of it too.
Wow.
I know. It's just people need to think that, do I really have to build out of this stuff? And we've got this problem over here. What if we use that? Mm-hmm. Or I've got a problem here with my health. What can I do to have a healthy house? You don't necessarily have to look in the real estate section and see what's being built. Mm-hmm. You know?
Fascinating. Yeah, that there's so much momentum and reflexive thinking, actually. You know, I know how to build a house. I know how to build a wall. Mm-hmm. And you exclude, implicitly in that you exclude. Okay, so we're getting close to the end here. I think the last subject I have is, let's say I've, first of all, I'm about to deliver a house for myself and my family, and I have the presence of mind to consider earthen construction and its benefits, and I decide I want to do it, mm-hmm. and then you and I initiate a construction process. What does that look like? And I guess what I'm thinking of specifically is one of the quote-unquote benefits of hollow, lightweight wall assemblies is I can put my electrical wires in there, right. Plumbing in there. Mm-hmm. How do you deal with services? Well, before we go to deal with services, what's the construction process? You put a foundation in. Mm-hmm. And you told the structural engineer for the foundation, this is going to have a wall that's going to weigh X on it.
Yeah, right. I know of only one engineer, and he lives in Austin, and long may he live, who is a big fan of earthen construction. He knows exactly what to design without over-designing.
Fantastic. Who is that?
Michael Donahue.
Michael Donahue. Fantastic.
Yeah, wonderful guy. And we're talking about alternatives even to what that is going to be. As a matter of fact, he's in charge of our research arm at the Earthen Construction Initiative. And so he's really behind.
He's a structural engineer.
He's a structural engineer.
Fantastic. Okay, so
we got him on board.
Architect? You're the architect?
Yeah, hopefully I'm the architect. If not, somebody else who knows about the material. And so there are aspects, of course, you can't, for example, have a really huge wall of glass, mm-hmm. Because, well, it's just the strength aspect of it.
Right. Some columns or something. What is the widest comfortably aperture that you're confident would be fine? Is it 6 feet, 8 feet?
You can go 6 and 8 feet, sure. And you could even have something wide enough to, for a garage door, that sort of thing.
That's 12 feet typically, right?
It's 8 to 12. Sometimes 16 if you want to do those double car garage doors.
You could even do a 16.
You can do it. There's nothing that says you can't. The thing is that once you start messing with your earthen to non-earthen opening proportions,
like the rented floor area too.
Exactly. All that stuff starts messing with what your attributes
some of the
are.
benefits.
Exactly. And so I would, for example, if you're doing a car in a garage, that's a different structure anyway. And be selective about your windows as far as views and natural lighting and that sort of thing. But Yeah, there's some aspects to look at, but you're not going to be living in a windowless house.
Right.
You could make these houses look very much like what a conventional house would look like, but ideally you're using a plaster exterior. And for at least the time being, most of the roofs are going to be conventional roofs.
Mm-hmm. With a truss.
Yes.
A wooden truss.
Mm-hmm. And so...
okay, so I've got that. It could be 1 or 2 stories.
Right.
And now my electrician walks up.
Mm-hmm. You have that in advance, and there's also, you can actually go behind the baseboard and do electrical runs, but it's easy to dig into the block to put the electrical in.
And that's okay. It doesn't affect it structurally. It's just a small...
No. Personally, I like to design structures where you don't have plumbing in the exterior wall.
Mm-hmm. Oh, yeah.
I mean, there's a sink like that sink there. Radio people can't see there's a sink in this room, but the plumbing for it can come in and out of the floor and go down into the floor. It doesn't have to be in the wall.
That's right.
And so I like to keep plumbing out of the wall anyway. And most of the walls in a house are interior walls anyway, and they'll be conventional. You don't have to have earthen interior walls. And then you've got the usual what you would do if you wanted to adapt your electrical later on. But most of the time when people buy a house and build a house, they're not going to do a whole lot of modification electrical plumbing anyway. Mm-hmm. But if you do want to do that, even on an earthen wall, it's not that big of a deal to add and things.
Very good. So the electrical, plumbing, heating and cooling, similarly, it could go up in the attic and do ceiling supplies and things like that. Mm-hmm. Is that right?
Sure. Of course, ideally, you're doing the RV system, and that you don't have to worry about the ducts and all the things that you have.
So you prefer ductless even?
Oh, absolutely. Mm-hmm. Absolutely.
And we talked about its ability to stabilize temperature and in terms of hygrothermal performance, it's going to be a moisture buffer. It's going to be a hygric buffer.
Yes.
Stabilizing humidity. Is there data on that, on temperature and humidity stuff?
Not yet. We just have, just consequential sort of qualitative but not quantitative, feelings about what it is. But that's one thing the ECI we're going to be doing is as these are built, and we've got one structure in San Antonio that's finishing up right now that we want to data log the heck out of, so we can see really what the fluctuations are and what is happening.
Fascinating.
And see how we need to fine tune how small can we get the cooling load, for example, and what do we need to do with the dehumidification to get this to work. And even that might be sort of a long-term test, because these blocks are a little bit damp when they're put in place, and they will dry out over a long period of time too. So their performance on year 1 will probably be much different than year 10.
Interesting. Have you have you ever lived in an earthen building?
I've spent the night a few times, but I've never really lived
an older one, or
not yet. Right. There was one out in the desert near Presidio.
Interesting. And so this project in San Antonio, is it a house? It's a home?
It is
test building.
It's part of Esperanza Center. It's a West Side nonprofit group, and the women of the neighborhood are using it to make ceramics.
Fascinating.
And so this is going to be their workshop.
And so you're going to instrument air temperature, air humidity, and try to get some surface temperatures.
We're going to do whatever we can. We've got to find out what hardware we need, how to actually get it set up, and get the data. And once we get the data, we'll have that free for the world.
Again, for you Building Science podcast listeners, the reason we brought Stephen on is because of this vision of the art of the possible when it comes to delivering conditioned space that includes monolithic high mass wall assemblies, ones where the enclosure does the heavy lifting in terms of a lot of the performance benefits, right? So we talk about health, comfort, safety, durability, energy efficiency benefits from this construction technique. It's the original green, all off grid. Any final comments, Stephen?
I think that pretty much hits all the high points. Of course, I'll be on the way home and I'll think, oh, damn, I should have said this. But,
that's okay.
I'll be in touch.
We could put it on the show notes or something.
Right.
Okay, well, thank you for joining us, and thank you guys for listening.
Thank you very much. Perfect. Good job.
We're out.
Thanks.
How long was that?
sure enough, Stephen had a few amendments.
One thing I'd like to add about stabilization of blocks, even though we had mentioned earlier how much important it is to have stabilized block with Portland cement or some other material, there are some people out there who are in the earth and construction business who actually prefer not to use stabilized block, and they come up with something with materials that are just fine. The important thing is, whether it's stabilized or unstabilized, and especially unstabilized, if you're using a stucco or plaster that is durable and will keep wind-driven rain from penetrating into the block. So that's the important thing. As long as you've got something that can really be resistant to heavy rainfall, you can have a very durable building that can last many, many years. Referring to the rubble trench foundation, the engineer I like to work with, he doesn't like that phrase so much because it implies that it's something that's sort of sloppy or haphazard. The word he would like to use, or the phrase he would like to use instead of rubble trench foundation, is compacted aggregate foundation, because the size of the aggregate makes a difference, and so is the placing of it and vibrating it into place, so you have a very controlled foundation rather than just pouring a bunch of rocks in and thinking that's got the job done. And so that's the only other difference, changing the phrase rubble trench to compacted aggregate.
Don't forget, please leave us a review on iTunes and share this podcast with your friends.